103, second half of section 1.3. All right, so remember for the first half of section 1.3, on page 100, they gave us 6 graphs that they said we needed to know what those 6 graphs look like. Now, most of those are graphs that we already knew, but just good review for us. And so the purpose of that was, if I know what those 6 graphs are, and I know how to horizontally or vertically shift those graphs, then literally they could give me like an infinite combination of equations that I would know how to graph without having to plot a single point. And since our textbook is called Pre-Calculus, a graphing approach, we have a pretty good idea that we're going to be doing a lot of graphing, and I don't want to be making XY charts all the time if I don't have to. So we learned in the first half of this section that any value subtracted from x caused a horizontal shift, and any value subtracted from y caused a vertical shift. So we want to add a few things to that today. Today we want to look at, what if you throw a negative out in front of x? That's going to cause a reflection, and there are actually 2 different types of those that we want to look at. Or what if we throw a number out in front of the function, like we throw a 5 out in front, or we throw a 1/2 out in front? How's that going to change it? That's actually going to cause something called a vertical stretch or a vertical shrink. So those are the things that we want to look at today, continuing at that same idea of, if when I see the equation, I know what transformation is being done to that equation, I don't need to make an XY chart to graph it. I'll just know how to sketch its graph instantly. So on page 103, they talk to us about 2 different types of reflections. And they tell us that you can have reflection in the x-axis, or you can have reflection in the y-axis. All right, let's start with reflection in the x-axis. It's as if we took this L right here in the first quadrant, and we folded our piece of paper on the x, let's start with x. If we take our little L and we fold our piece of paper on the x-axis, then that red L would translate down here to the black L that you see. That's what its reflection would look like. Now, when we think of reflection, we think of like looking in a mirror, right? You know, you look in the mirror and you see your reflection back. It's that same kind of thing. It's like the red L has looked in the mirror, and this is the reflection that it's seeing back. If you have writing on your shirt, when you look in the mirror, it looks backwards, right? It's not the exact same image. Similarly, reflection in the y-axis. If we take that same red L in the first quadrant and we reflect it in the y-axis, then if we reflect across this line right here, then we'll get the black L reflected image that we see. All right, so the way the equation is going to look to tell me to do that is, if I put a negative out in front of the whole function, that's going to cause a reflection in the x-axis. The easiest way for me to remember that is, you know how we've already learned that if you've got y equals ax squared, like a parabola, and its leading coefficient is positive, we've already learned if it's positive it opens up, and if it's negative it opens down, right? What is that? Isn't that a reflection in the x-axis? So if you throw a negative out in front of that quadratic equation, the change that it makes is it makes it open down instead of open up, right? That would just be reflection in the x-axis. So to me, that's an easy way to remember it, because that's something that I already know, that I've already memorized. So then what is reflection in the y-axis? Well, that's when I put a negative in front of x, and then I plug that into the function. I put a negative in front of x. I don't put a negative out in front of the whole function. I put a negative in front of x, and I plug that into the function. Let me show you what I'm talking about. Look at example number 4. Skip example 3 for a second and look down here at example number 4. For example number 4, it says if f of x is equal to the square root of x, and that's one of those 6 graphs from page 100 that we should know what it looks like. It looks like this. If f of x is equal to the square root of x, then what would the graph of g of x look like if g of x is a negative square root of x? So I put our original function on there just so we can kind of use it as a guide to graph the new function g of x. We said that if you put a negative out in front of the entire function, that's a reflection in the x-axis. And that's exactly what they've done right here. They've got a negative out in front of the entire function, so that's going to be reflection in the x-axis. So just like we did this with our shifting, we're not going to plot points. We're not going to be real precise here. All we're going to do is take that original function and just reflect it in the x-axis and just sketch what that new graph would look like. Doesn't have to be perfect, just as long as I can see you know what you're talking about. Okay, well, if that's what reflection in x looks like, then what would the equation look like if they wanted me to reflect it in y? Well, that's what we see in our second example. H of x is equal to the square root of negative x. If you'll notice, my original function was square root of x. If I'm supposed to reflect in the y-axis, I'm supposed to put a negative x in the place of x and plug it into the function. So if I put a negative x in the place of that x right there and I plugged it into the function, I would get the square root of negative x, right? That's exactly what this is right here. So that is reflection in the y-axis. The negative is not out in front of the whole function. The negative is just in front of the x that got plugged into the function. Do you see the difference between those two? Okay. So reflection in x is when the negative is out in front of the whole function. Reflection in y is when the negative is just in front of x and then plugged into the function. Okay, so now that we've identified it, then we can actually sketch it. So we're just going to draw that exact same thing, only we're going to reflect it across the y-axis. And again, just a sketch, doesn't have to be perfect. So now they're going to take what we learned today, reflection, and put it together with what we learned in the first part of this lesson, that idea about horizontal and vertical shifting, okay? So if we compare the new function that they're giving us here with the original function that we've had, we have a couple of things going on. We have a negative and we have a plus 2. So I know that I'm going to have some kind of reflection because of the negative, and I know that I'm going to have some kind of a shift because of that plus 2. All right, so which reflection is that? Reflection in x or reflection in y? That one is reflection in x, right, when it's a negative out in front of the whole function. And do we have a horizontal shift or a vertical shift? Is that 2 being subtracted from x or from y? Can I move it to the other side and subtract it from y? No. So like we talked about on the first half of this lesson, if it's really being subtracted from y, if it's really a vertical shift, you should be able to move it to the other side. That 2 is underneath the radical. I can't move it to the other side. I can't just pull it out of there. It's stuck to the x. So if it's stuck to the x, that means it's being subtracted from x. That means I'm going to have a horizontal shift. All right? So what is being subtracted from x? Negative 2. Yeah, so negative 2 is being subtracted from x. That's x minus a negative 2 to give me x plus 2. Or we also said you could think of it as like the opposite of. So the opposite of positive 2 is negative 2. So horizontal shift of negative 2. We're going to talk more about this in just a minute with our next example. But when I am graphing, it's really important that I follow a particular order. I want to do my horizontal shift first, my reflection second, and then I want to put my vertical shift over on the left-hand side with the y value so that I can clearly see it. Okay, this is a vertical shift, and then do that vertical shift third. I'll show you in that next example that if I don't do it in that order, I'm not going to get the right answer. I literally will get the wrong graph. So let's follow that 1, 2, 3 order that we just mentioned while we're doing this graph, okay? So first I'm going to look and see, do I have a horizontal shift? I want to do that first, and I do. So I'm going to take that black graph and I'm going to horizontally shift it a negative 2. Then number 2, I'm going to look to see, do I have a reflection? And if so, I'm going to do that second. And yeah, I had a reflection in the x-axis. So take the red graph, the shifted graph, and that's the one that you want to reflect. Don't go back to the original. Don't undo what you just did, okay? So I'm going to take that red graph that I have already done the horizontal shift, and I'm going to reflect it in the x-axis, and that'll be my final answer. Now, you can draw a separate graph for each one of those, or you can draw each of the steps on the same graph, and then just in some way show me which one is your final answer so I know which one that you want me to look at when I'm grading it. to example number 3. In example number 4, they gave me the equation and they asked me to come up with the graph. In example number 3, they give me the graph and they asked me to come up with the equation. So we want to be able to go both ways. So for example number 3, it says, each of the graphs shown in the figure is a transformation of the graph of f of x is equal to x to the 4th. So find an equation of each function, okay? So we could say, all right, if this is f of x is equal to x to the 4th, looks a lot like a parabola, it's just a little wider at the base. So if that's f of x is equal to x to the 4th, let's look at what changed about that graph from here to here. All right, so talk to me. What's different about it from here to here? Okay, it's had a vertical shift down. What else? It was opening up and now it's opening down. So what would cause that? Yeah, a reflection, and specifically, as you said, in the x-axis. So, okay, this has been reflected. If I took that parabola and I reflected it in y, it basically would, again, not a parabola, it looks like it, but not a parabola. If I took that quartic and I reflected its graph in y, I'd basically have the same graph, right? So it wasn't a reflection in y that caused it to flip down. That was a reflection across the x-axis. So we've got a reflection in x. And then we also, it's been moved down. It was centered at 0, 0. And now it has a vertex at 0, -1. So it's definitely gone down 1 as well. So as you said, it's had a vertical shift. How do we represent down 1 with a vertical shift? -1, yes. All right, so when I write my equation then, I can say, okay, the original equation was y equals x to the 4th, and I need to alter it for these two things. So the first thing was reflection in x. Remember that when you have a reflection in the x-axis, you're going to put a negative out in front of the entire function. So let's do that. So let's put a negative out in front of the entire function. So we took care of the reflection. Now we need to take care of the vertical shift. And we said a vertical shift would be any value subtracted from what? Y. Vertical shift, any value subtracted from y. So all I'm going to do is come over to y and say, okay, I need to say y minus whatever my vertical shift was. That was -1. So y minus a -1 would be y plus 1. Y minus a -1 would be y plus 1. Now, let's say that they had given me this guy right here and they had asked me to graph it. Instead of giving me the graph, they gave me the equation and they asked me to graph it. Here's an example that shows you why the order of these steps is so important. Because if I said, okay, I've got y plus 1 is equal to a -x to the 4th, that's this guy that we just had right here. If I looked at that and I said, okay, there's a reflection in the x-axis and there's a vertical shift of -1. We said that I would have to do the reflection before I did the vertical shift, that if I didn't, I wouldn't get the right thing. Okay, if I started with that quartic and I did the vertical shift first, that means that I would have gone down 1 right there. So there's my vertical shift. And then I would have reflected that in the x-axis. That would have given me this guy right here. If you throw that into your calculator and hit graph, you don't get this pretty little picture right here. You get this pretty little picture right here. It's not the same thing. So the order that I follow does make a difference. So I want to be careful that when I'm doing the graphing, horizontally shift first, reflect second, vertically shift third. Additionally, there are some times that you could factor out a negative over here and then that would change this value to be what you need it to be to get the correct vertical shift, but sometimes it doesn't work. And so again, that's why I suggest to you that you put, if you have a vertical shift, that you take that value and you group it with the y over on the left-hand side. You get it out of the way to make it very clear to you, okay, here's my vertical shift, here's my horizontal shift, here's my reflection, so you can see exactly what you're working with. All right, look at this next one. Again, we're comparing back to our original function. If I compare this graph to my original graph, what's different? What's happened? Did I have a vertical shift? No, it hasn't moved up or down at all. Did I have a horizontal shift? Yeah, it's moved to the left, so I did have a horizontal shift. Has it been reflected, or is it open in the same way it was before? It was opening up, and now it's opening down, right? Yeah, so it's been reflected. So I have two things going on here. I have a reflection. Is it a reflection in X or in Y? All right, if we had a reflection in Y, we would have that same picture that we started with, right? If we have a reflection in X, then it's going to go from opening up to opening down, right? So we have a reflection in X. And then you said we had a horizontal shift. What's our horizontal shift? -2, right, because we went to the left 2, and we represent that with a -2. All right, so our original equation was y equals x to the 4th. So we need to deal with reflection in X, which is a negative out in front of the whole thing. And we need to deal with a horizontal shift. Now, with that horizontal shift, any value subtracted from X is a horizontal shift. So X minus a -2 would give us X plus 2. It's also important that we tack that 2 to the X, that it can't be moved to the other side. So that's why we put it inside the parentheses and raise it to the 4th power as opposed to putting it outside. And then, of course, our negative out in front that we already mentioned for our reflection. All right, so over on page 105, they talk to us about rigid and non-rigid transformations. And they tell me that the transformations that we just did, the shifts and the reflections, the shape doesn't change. That's called a rigid transformation. But the non-rigid transformations are when I stretch or shrink the graph. Now, you know the house that I live in. I cannot hit the word transformation without thinking Transformers, because all the boys in my house are obsessed with Transformers. And, you know, Transformers, like a car changes into a robot, right? That shape is distorted. It doesn't maintain the same shape. And it reminds me of Romans 12:2 that says, don't be conformed to this world, but be transformed by renewing your mind. It's so easy for us to be impacted by all the pressures that are around us and conformed into this little cookie cutter mold of what the world says we should be. So how do we avoid that? Well, Romans 12:2 says, be transformed. We should look as different to this world as that car does from that robot. We should be absolutely transformed by renewing our mind, by focusing on Christ and the things that are truly important and the things that are really priorities. So what is a vertical stretch or a shrink? They tell me that if you have a number out in front of your function, like a C value, if that number is greater than 1, it's going to cause a stretch. If that number is between 0 and 1, it's going to cause a shrink. Did you ever play with silly putty when you were a little kid? Yes? No? Came in a fun little egg like this? Looked like this, only most of them, they come in fun colors now, but originally they were kind of like a tan color. And you could put your silly putty down on Charlie Brown's face on the Peanuts comic strip in the newspaper and pull it up, and when you did, Charlie Brown's face was on your silly putty. It was the coolest thing ever. And if you grab the top and the bottom of your silly putty and you pull up and down, that is a vertical stretch. If you pushed it back together and shrunk it down, that's a vertical shrink. That's the easiest way to think. So if I had the original function, f of x is equal to the square root of x, and I threw a 2 out in front of it, that's going to cause a vertical stretch by a factor of 2. It's just going to make it go twice as high and twice as low. So I literally could say, if this is the original, I'm going to make it go twice as high as it was before. It just doubles every one of my y values. If I made an xy chart, sure enough, every one of those y values is just doubled. So what do you think is going to happen over here if we throw 1/2 out in front of this thing? Yeah, half as high, right. That's a vertical shrink. Where, again, I could make an XY chart if I want to, but every one of those values is just going to end up being half of what they were before. And if I sketch that graph, sure enough, it just goes half as high as it was going before. That's a vertical shrink. Okay. All right, so here is our homework for tonight on page 106.